Do you want to run down and look for it real quick? And then you're supposed to be doing stuff with your phone, right? So I'm just reminding you in case you need reminded. All right, so we have two choices here. Win on a black card greater than or equal to 9. Win on a red card less than 9. So if you want to write this, I don't know, in your graph paper, in your notes, in somewhere. So if you don't have graph paper out yet, you're going to need it today. We are actually going to use it today, that's for sure. And I'm definitely going to use cards, because why not? We're talking about cards.
How do you know my gamer tag?
Your gamer tag? I don't know your gamer tag.
You just say spoke right now.
What?
You know my gamer tag.
I don't think I do, man. I think you're making stuff up. All right, so if we're looking at our probability sheet here to help us out, we're talking black card greater than or equal to 9. So, Misk, can you help us know what our chance, if we chose choice A, what our chance would be to get a black card greater than or equal to 9?
So to get a black card, that would be like 50%, but then to get one that's above 9 would be like...
Ooh, 9 or above, right?
Yeah. 8? Oh wait, no. 8
There it is.
over 52.
So let's double check that because you sound like you got a little question mark in your voice, right? A black card 9 or greater. So 9, 10, Jack, Queen, King. 9, 10, Jack, Queen, King. Because we said 9 or greater, right? 9 or greater than or equal to 9. So 9 counts. So how many of those cards are there? 10 out of what?
52.
And guys, do we have to reduce this? No. Nobody said we have to. And if we're going to compare probabilities, we could leave it unreduced and just leave both of them unreduced. So what about Margot, our red card of, what'd they say, less than 9? Nope, that's the wrong symbol. No, that's the right symbol. Less than 9. So how many, Margot, how many red cards less than 9?
Wait, no, that's not the right symbol.
Yeah, so 8, 7, 6, and we're going to count aces as 1s here. So there's 8 and another 8. So yeah, there's 16, and that would be over, what our denominator be there? 52, because that's how many cards are in a deck.
Wait, Mr. Hudson.
And so guys, what choice, Donovan, what choice are you going to make? Which do you think is more likely? Yeah, the red one by 6 more cards. Now, hold on. Does that mean you'll for sure, so you guys agree, choose red? Yeah, red? Thumbs up? Can I get it? Because we got to agree. Do we agree? Choose red would be the better choice. Yeah? All right, so you got red. I'll take choice A then. I'll take black card 9 or greater. Now, if these are when you win and when I win, is somebody always going to win? No, there are cards that don't make any of us win. So let's shuffle up and see what happens.
It's gonna be black.
Wait, okay, so this is 10 out of 52. This is 16 out of 52. Sorry to keep you in suspense. What's the chance? We'll give the rest to Miss Hassanin, right? So if we'll say Miss Hassanin wins on everything else, so the probability of Miss Hassanin, so there were 10 cards that make me win. There were 16 cards that make you win. How many cards would be left over that would make Miss Hassanin win? Christian, how can we find this?
10 plus 16 and then minus 52.
So like we did yesterday, finding like the complement, right? The rest of it. What's 52 minus, not 16. What's 10 plus 16? 26. What's 52 minus 20?
26.
26. So wait a minute. What's Miss Hassanin's chance of winning?
50% chance.
1/2, right? Oh crap, she's got a better chance than all of us. All right, so we shuffled. You ready? You ready?
Yeah.
Who wins?
Red.
Red.
Miss Hassanin. Because that's not red less than 9. That's a red bigger. Crap. Miss Hassanane, you got 1 victory. Is she over there?
Yeah.
All right, you got 1 win. You ready again? Who wins? No, Miss Hassanane again, right? That's not 9 or crap.
Yeah.
No, you win.
Yeah.
Right? That's a you guys.
Yeah.
Because that's less than 9 red card. All right, so you guys got 2 wins. Or sorry, you got 1 win. Hassanane's got 2 wins. Who wins? You win again. Ooh, now it's 2-2. I got nothing.
We had a 30% chance of winning. There's 90% chance of you.
Who wins?
We-
Crap, you got... So guys, what if I want to do this game like a bunch of times, but like not, and actually I should be shuffling these cards back in technically. What could I maybe do? What could I maybe use to like figure this out over and over and over again? A computer. So today what we're doing is computer simulations of probability to help us be able to do things either a lot of times or just more easily than we might have before. But before we get into that, let's check homework. So if your 521 is done, you should be checking it. If it's not done, you could work on it real quick right now, but you're not copying answers.
5-2-1.
We're not, 521. So
I thought it was 5-1-2.
yes. Sorry, I am backwards, which means I just need to pull the PDF up. My bad, I grabbed the wrong one off of here. 512, thank you, Gabe.
I was about to say I'm wrong.
I just did that whole paper for nothing.
No, 512, my bad, 512. 512, if it's not done, you need to make a mental note. It's due tomorrow. It's due tomorrow.
Like the other one.
You might have already checked it in Schoology. Tomorrow is Friday, thankfully. I need the weekend. I also need to catch up on homework because I was out real late at my meeting last night.
Not good.
No, we didn't end our meeting till 10. What is wrong with us?
Yeah, what is wrong?
I don't know. Well, we're trying to save our organization from going under. Any questions? I can zoom a tiny bit more. So guys, you can't see 512 when I'm zoomed in that far, but this is 512. Because if you get a wrong answer, that should like activate you either asking a question to yourself or asking a question to me. No questions? All right, so guys, again, in your Chromebook, you should not be going to Homework Help. You should not be going to Desmos. We're going to the ebook. So if you're navigating through Schoology, it is the first link in our links folder, CPM ebook. This is not Homework Help. That's where we're going. Then you want to find lesson 522. Guys, I always leave Schoology. It just makes the screen a little bigger, easier to work with. Lily or Raphael, there's paper under your desk. I don't know if that's important to either of you. You probably only have the blue book, but don't click on the one that says ESP. That is Spanish, unless you'd like to view it in Spanish. 522. And guys, check it. Look up at my screen real quick. This button right here is your full screen. So if you want to make your life a little bit easier and get that toolbar out of the way, click this button and it full screens it. What you're looking for is this 534 Student E-Tool. That's what we're looking for. Then there's one for 35, there's one for 36. There we go. So I'm trying to wait just a minute while we're getting logged in and where we need to be. What up?
522.
522. Yep, like we're going dancing.
Yeah.
Maybe log in. All right, right, so let's play a new game because was that game we just played fair?
Not
Who
really.
can tell me why it was not fair? We talked about what it means to be fair yesterday, Jana.
We all don't have equal chances because the numbers are all different.
Yeah. My chance was the lowest. Your chance was kind of in the middle, and Miss Hassanin's got like a really unfair chance. She had a 50% chance. It wasn't fair. It's not fair at all. So let's try a new game. Let's just do numbers. So, in game one, we're going to analyze if these games are fair and what the different chances are. In game one, a prime number. Now, you and your partner might need to remind each other what's a prime number. A prime number gets you the win. Let's figure out what the chances are of player X winning there. What's up? Do I have a what? Funny enough. Actually, funny enough, every teacher has a hammer. Because in our little emergency bucket thing, be careful with that, okay? Well, she probably just forgot. This is like an emergency bucket, man. People don't think about, yes, I had a hammer in there.
Is it for the social studies assignment? Yeah.
Hey, make sure you don't like make any poor choices with that, okay? I just gave a middle schooler a hammer, and now I'm lightly regretting it. Minorly suspicious.
I once gave my asked my sister how to wear something I was working on, and I told her that I should be the hammer.
What?
She said she did get it.
Already talked. Ivan, can you remind us what a prime number is? Yeah, numbers that are only divisible by 1 and itself. So guys, hold on. This is a long time argument. Is 1 a prime number? Turn to your neighbor and share your opinions. What is 1 a prime number?
Isn't any number a prime number?
Prime numbers are only divisible by 1 and themselves, nothing else. So like even numbers are not prime, right? Because even numbers are divisible by 2.
Yes, it would be a prime number.
And guys, even though I have like a fancy piece of paper that says I know math, I even have to Google stuff, right? And even if I think I know it, I sometimes need some reinforcement of like, I don't want to act like I know something, right? Thinking about Mr. Estes here, teaching you guys, don't act like you know things you don't. I don't want to act like I know it, so I go to Google to double check it because it sounds like 1 should be prime, right? But it isn't. Every reference I look at here, mathematicians decided at some point, like they all got together, and they're like, we have to make a decision, is the number 1 prime? And they decided no, because of some other fancy things that they talked about that we don't need to get into. So the prime numbers, and I forget if I put this on any of your math notes or not, this is probably one of the best things to just be able to see prime numbers quickly. So if we're going to generate numbers between 1 and 20, right, 1 and 20, you and your partner need to figure out what is the probability of prime. And I will leave this up here. But what you want to figure out right now is what is your probability of prime?
Is blue the prime number?
Blues are the prime numbers, yep. They're highlighted to show prime.
There's 8 prime numbers. So there's 12 left over. But then we have to add them together. Oh, that's 20. So 8 out of 12. Oh, wait.
That would mean that you got
Isn't it 8? I got 14. 1 and 2/3.
wait, no,
This is why we're reviewing it, because it's on your practice work.
8 out of 20.
Now,
Oh, out of 20.
Margo, you want to say that louder?
8 out of 20.
So those of us that have our brains turned on and are like analyzing, okay, I should phrase it differently than that. But Margo is really thinking today, right? Margo's kind of getting the MVP. Margo just wanted to let us all know this is A from your homework. This is also part of my lesson, but this is literally problem A from your homework. like the first problem, part A. Chance of getting a prime between 1 and 20. Because if you pull out your homework sheet, if you have it out like I had on the start screen, you can do your homework problem right now. You can do part A right now. What is our chance of prime between, so we're going to write prime 1 to 20. So what is your chance of, oh guys, I'm going to use cards. So I got too many hands up. It stresses me out. Raphael, you want to help me out with how many prime numbers we have between 1 and 20? Yeah. So 2, 3, 5, 7, 11, 13, 17, and 19, because all of those can't divide by anything else. So our probability of a prime between 1 and 20 is 8 out of 20, right?
Wait, wouldn't that be 40%?
You guys are intense today. I love it. But Gabe's actually raising his hand. Gabe,
Okay.
question, comment?
You can actually simplify a 20 to 2 out of 5.
So we can, right? Do we
yeah.
have to?
No.
Okay, so you're right. We could. But for a moment, guys, look at part B. This is right here. Part B is a prime number between what? 21 and 40. So figure that out right now and just do it on your homework.
Okay, so 21.
What's our chance of prime between 21 and 40?
4. So there's 4 there.
Yeah, there's 12 total. Well, yes, there's 4.
So that would be
4.
a 40%. No, that would be a 2%. 20% chance of getting that.
Yeah, you're right. The first one would have been 40% because you multiply by 5 on top and bottom. The only issue is this is not going into my recording because I'm writing on the screen. Lily, can you help me out with what is our chance of prime here? 4. Now 1, 2, 3, 4. So guys, if you had to choose 8 over 20 versus 4 over 20, which one would you choose for better probability? Yeah, it'd be 8 over 20. It's twice as likely. Twice as nice.
Twice as nice.
Wait,
Wait, why does it say 20 on the bottom?
because there are 20 numbers. If you count 21 through 40, yeah, because 21 up to 40. Whoa, I was still more right than you.
I said 19 because
All right, back to the lesson. What, you don't snap your fingers in a Z formation?
no. I said 19.
All right, so now, back off of your homework. Hey, back off of your homework. At least I think this is not on your homework. Now we're going to talk about even. How many even numbers are there between 1 and 20? Turn to your neighbor real quick. Don't think you'll need very long. Yeah, I think these problems help you with your homework, right?
Gabe said the E word.
Jana, what's your probability of getting an even between 1 and 20? 10. Yeah, we always need that over the total, right? 10 or wait, a number not divisible by 3. Well, so let's think this through. If I'm just gonna pull this back up, but like let's ignore the prime color coding. Let's cross out the numbers that are divisible by 3. Right? So what numbers are divisible by 3?
9, 6, 12, 12, 15, 18.
Okay, so how many numbers does that leave us? Well, 1, 2, 3, 4, 5, 6. What's 20 minus 6?
14.
14. So this gives us actually a number not divisible by 3. That's going to be 14 over 20. Guys, what did we say the prime number chance was for 1 to 20?
10 out of 20. Wait.
8. Well, this one was 8. Yeah, this one was 8 over 20. So wait, which of these would you, if you're player X, which of these games would you rather play?
The last one.
The last. Your chances are the best.
Nah, I would actually do the game one.
Well, not cleanly, not nicely, right? It doesn't come out to be a whole number. To be divisible, your result needs to be a whole number.
I want
So yeah, Moss was reminding, well, technically you can divide anything by 3, but when we use the term divisible, we mean it comes out to be a whole number, right? It comes out to be a nice answer.
Nice.
So if you're player X, you're choosing game 3.
I'll choose
I agree. I think I probably would too.
I'll choose-
In your ebook, though, question or stretch? Ooh, this one, thank you for that. This one we were talking about the divisible by 3. So I know I used the prime chart, which maybe I shouldn't have done that. But this, we were crossing out the divisible by 3s. Does that make sense? You're right. Let's double check they didn't get this wrong. Yeah, they didn't mark it as prime. We crossed it out for divisible by 3. Thank you for that, Donovan. So in your ebook, if you click on this, right, it should be in front of you, hopefully. This is one of the tools built into CPM so that we can actually do this. Now hold up real quick. What we just did, the fractions we wrote down, did we actually test it out? No, we just looked at it, thought about it. That is what we call theoretical probability. And this is in your math notes packet, right? So you don't really need to write anything down right now if you use your math notes packet. Theoretical, guys, give me your eyes real quick, because this is my memory trick that hopefully will work. Theoretical is when we only think about it. Experimental is the other kind of probability. And what do you think that means we need to do?
Experimented.
Do the experiment. So in your number generator that you just pulled up, we're going to do this 20 times.
Yay!
Let's write down the numbers that we get. Well, actually, let's pick who we're going to pick. What? Player 3?
Yeah.
So if we, or game 3, do you guys all agree? Do we agree as a class that we want to play game 3?
Yeah.
Because you all are player X. Yeah? So let's keep track of how many times you win. Let's say I win if you don't. So if it is divisible by 3, I win. But what's my chance? 6 over 20, because it's the rest of it. Right? So my chance is 6 over 20. Your chance is 14 over 20. Let's see what happens. This first number doesn't count. Right? That's right. It does not count. Let's rewrite. No. All right. So who wins? You or me? Actually, somebody want to come up and keep track of this on the board?
Can I?
Sure.
June.
June, get up here.
Let's go.
So let's label this class versus Hudson.
What about Miss Hudson?
Sorry, she's not in this one. She had too high of a chance in the last one. All right, so you guys take the first victory.
8.
Yeah, so just put a tick mark for like you guys won. Well, you guys won again, because that's not divisible by 3, right? Again, you guys win. Gosh, I'm not doing very well. Again, you guys win.
Again!
7, again, you guys win. Again, you guys win.
Again!
How rigged, guys? When you start thinking, "Oh, this is rigged," this is CPM. It's a code. Like they wrote a computer code. It's random. So even though I just got 17 twice in a row,
Wait, Mr.
it
Hudson.
is random. Like I promise you,
On my
it's
computer,
random.
you're winning.
Well, no, you guys are winning like crazy. Ooh, I got one. I got one.
Let's go.
So it's 1 versus 7.
Yeah.
At the end of this, it should end up 6 versus 14. Hypothetically, it should end up 6.
Your chances are like 14 out of 20, not like.
Does that mean that's what will actually happen? Ah, that's all right. So we got to keep going. You guys get this one. 9. I get this one.
By the power of June's face on that picture.
11. You guys get another. 12. Haha! I get another. 11. You guys get another. 10. You guys get another.
It's my face. That's so weird.
13. You guys get another. 11. You guys get another. I think I should have somebody else tap the screen.
I'll do it.
Alex, come. We got 3 more.
Easy.
10, 3, 16.
I've been. What did you just say?
Raphael said it too.
So go ahead.
5.
You guys win again.
You guys are naughty little kids.
Oh, there's one for Hudson.
Mr. Hudson, you're a winner in my mind.
Oh, thank
Oh,
you.
that's sweet.
Hold on, we got so. Ooh, another one for me. Hey, another one for me.
You
Julie.
have your first.
Hold on. This is number 20. This is the final one. Make a guess in your mind.
I wonder
Do you
who
think-
will win.
Do you think you guys are gonna get it,
No.
or do you think I'm gonna? Like, I have no control over this. It's actually random. Alex, go ahead.
Mr. Hudson.
Hey!
Told ya.
All right, grab a seat.
I have a seat. I grabbed the seat.
Thank you.
I grabbed the seat.
Give me your eyes real quick.
He said it.
This is not rigged, or whatever you want to call it. This, hold up. You need to leave. You're not getting a reaction from me. It's not going to happen. But what you will get is kicked out of class. You want to leave? Okay. Then fix your behavior, because you're just talking over me, and I can't deal with that. This is called the law of large numbers. If you do something enough times, what should happen probably will. Because mathematics does what it does, right? Like, we've studied this for a long time. If I roll my dice, like, enough times, I will get all of the results that I expect, probably. Which, guys, this is, like, one of the things that makes people addicted to gambling. Which is why anytime I teach probability and stuff like this, I always want to talk about gambling is set up for you to lose. The only way the casino is as fancy and nice as it is a bunch of people lost money. You will eventually win. But does your one win cancel out all the money you already lost? No. Yeah, like some got lucky, right? Like if you actually got lucky. But guys, this has been studied. It's dopamine. It's the thing in your brain that makes you feel good. And like when I teach probability, I really got to say casinos are rigged against you, but they're not rigged. They set the math up to make you lose. Seriously, the math of a casino is you're going to lose, they're going to win. Probability-wise. Dave?
I just looked up what the chances are of winning the lottery, and it says it's a 1 in 292 million chance.
Depends on which lottery, but yes. Yep. Yeah, your chances are more likely that you're going to lose. But somebody is going to win, and that hope is what gets people to continue playing. All right, let's try another game. Let's do... Ooh, anyone want to go to McBurgers?
Me.
Because McDonald's is trademarked and they couldn't put McDonald's in the book. All right, so go back to your ebook. And find the link for 35. Right, click on the 35 e-tool. You're going to do this now, and you're going to take 5 trips to McBurgers. Here's the situation. You're babysitting over the summer. Yes, boys, you can babysit too. It's good money. Don't break their light in the basement by jumping on the trampoline, though. Then you'll lose your job babysitting. Who puts a trampoline in the basement? The kids I was babysitting had a trampoline in the basement, and I was on it playing with them, and my head hit the light, and it broke, and the whole thing. They did not invite me back. So, mistakes happen, whatever. You're going to McBurger 5 times. The kid you're babysitting wants all 3 toys. Figure out in 5 times, will you get all 3 toys? The toys are labeled 1, 2, and 3. So try this. On your computer, go to McBurgers 5 times. So like click it, that's your first trip. Click it, that's your second trip. That's toy number 1. And if you get another one, you got the same toy again.
You got 2 toys.
You only got 2?
I got all
I got-
3.
You got all 3?
Wait,
I got all 3.
You got all 3? You got all 3? And
2.
did anyone get all 3 in just 3 trips?
Yes.
Keegan, you got all 3 in just 3 trips?
Yeah, I got all 3.
So Keegan like got lucky there.
I didn't.
You're on the wrong e-tool. You gotta go back to the ebook and go to 35.
I got 2.
Go back to the ebook. Show me how to do it. And then go to question 35. only goes 1 to 5.
Just making a helicopter.
Did you guys already do? Yup, I got 2 toys.
There's no toy number 4.
You got
Or sorry, it should only go 1, 2, or 3. But you're going 5 trips. My bad. I mixed my numbers up there.
I got one.
All right, so let's see what happens when I go to McBurger.
I got
Trip number 1, I get toy 2. So trip number 1, I got toy 2. Trip number 2, I got toy 2 again. Great. I have 2 of the same action figures. They can fight each other. I got toy 2 again. That's 3 of my trips.
Ah!
what?
Ah!
And so hold on. This brings up a question. Gabe, can you guys quit helicoptering? Because it just distracts me. Like, you're not really doing anything bad, but like, I can't focus. Sorry, it's me. It's my fault. Bully, can you just please work with me? Oh my God.
Why did you say it?
It's a Taylor Swift song. Right, T Swift? Yeah.
Yeah, we all like Taylor Swift.
I mean, even I like Taylor Swift, but that was unintentional, T Swift.
Yeah, it just popped
So,
in my head.
Guys, what? Hold on. Give me your focus up here real quick. I'm trying to figure out what to write with because all my pens are gone. I guess I'll just use my finger. What was my chance of getting toy 2?
It was
What was my chance of getting toy 2? How many toys were there?
3.
1 in 5.
Donovan?
Well, what June just shouted out wasn't right, so
Wait,
that
what?
made you say never mind.
But we
Ooh, the experimental. I wasn't even ready to go there, but you took it. The experiment we just did. My chance of getting toy 2 was 4 out of my 5 trips. Is that is that the theoretical chance?
wasn't my theoretical chance.
Christian, it's really easy to tell you're not with me. What? These only go up to 3. I know, my bad. I misspoke. I didn't get home till 10:30
Yeah, that's why
last
I said
night.
it
My brain's
too.
not quite 100% today. According to the model, guys, this is like what I'm supposed to teach you. This is where we wrap it up. The model, Donovan. Ooh, how many toys are there? 3. How many of them is toy number 2? 1 of them. So according to the model, what was my chance of getting toy 2?
1 in 3.
1 in 3. Is that what happened? No. I got it 4 times in a row. So will the experiment always do what we expect? No. Guys, probability, you can try to predict it, but you can't figure out what's gonna happen. Keegan? Yeah, I know. Yes, because see, you're smart. You would actually just go say, "Can I have that toy? I need to finish my collection." Keegan's got a solution for us. Yes. Go inside. Ask politely.
The probability that this class will end at the right time is like
0.
Careful,
And what?
careful, Moss.
Moss.
He's throwing shade at my
Dangerous
ability to keep track of
territory.
time. All right, you guys want to do one more?
Yes.
Go back to your e-tool. Go back to your e-book. Sorry, I said e-tool. And go to 36. Moss, you all right? All right, hold up. Janelle's aunt and uncle have 3 children, 2 of whom are girls. Assuming that girl children and boy children are equally likely, which pretty much guys, male, female, it's about an equal chance of what gender baby are you gonna have. Janelle thought that the chance of having 2 or more girls out of 3 children must be 50%. Janelle's brother thought the chance of having so many girls had to be less than 50. So let's use a computer model to figure this out. So before we do that, and you may have already started clicking things, but before we do that, what do you think? If you have a family of 3 kids, what's the chance that 2 of them are girls? Is it more than 50% or less than 50%? Just in your head, take a guess what you think. Keegan, did you want to share something? I don't know. We got to figure it out. We got to use our model to help us. So in this model, So make sure we read the instructions over here. Modify the generator. I forget. Maybe I broke this one. Because I think there's supposed to be more. Use a 1 to represent a girl, a 0 to represent a boy. I think the 0 is just not actually showing up.
Is this one's 10?
Is it working for you guys that when you click it, you see the number? Because
Yeah.
it's not working for me.
Well, it just showed up real quick.
No,
I think mine like sort of broke.
Wait, zero for me was just blank.
We might need to skip this one. That tool seems broken.
Oh, the probability that Mr. Hudson will end this class at the right time is actually 0 right now. So.
Look out the window. Moss is silently.
All right, according to Moss, it's time to go. Have a wonderful day, guys. We'll do more with this tomorrow. Moss, you could phrase that like, "Hey, Mr. Hudson, did you know it's 9:55, 10:50?" Oh my gosh, I should stop. Whatever. Math is hard. Numbers are hard.
I agree.
Moss is the boss.
I should stop this recording before I make even more mistakes.
See you later.